Shapes and Angles Part 2. We're going to be looking at quadrilaterals and polygons. Let's start with quadrilaterals. So as the name suggests, quad means four, so we have shapes with four sides. So some common quadrilaterals include trapezoids, rhombuses, right trapezoids, squares, parallelograms, and rectangles. There are more, but these are the common. So for quadrilaterals, all interior angles add up to 360 degrees. Let's take a look at polygons. Polygons, as the name suggests, poly, many, so we have shapes with many sides. We have pentagons with 5 sides, hexagons with 6 sides, heptagons with 7 sides, octagons with 8 sides. Common one would be a decagon with 10 sides and a dodecagon with 12 sides. So for polygons, we say that a regular polygon is a polygon with equal side lengths. And for any regular polygon with n number of sides, we have a formula to calculate the interior angle size. So we say A is equal to 180 times n minus 2 all over n, where n is the number of sides that the polygon has. Let's take an example. Example 1. What is the size of each interior angle for a regular hexagon? So here we have a regular hexagon, so all side lengths are equal, and therefore all interior angles are equal. And a hexagon, a regular hexagon, has 6 sides. So let's take our formula, and we're going to substitute the number of sides, 6, where you see n. Okay, so now we can evaluate the brackets first. So 6 minus 2 is 4. 180 times 4 will be 720, and 720 divided by 6 is 120 degrees. So each interior angle is 120 degrees for a regular hexagon. Example 2. This one's a bit trickier. Which regular polygon has interior angles of 135 degrees? Let's go to our formula. A is equal to 180 times n minus 2 all over n. And we've got 135 degrees, so we can replace the A here with 135 degrees. And now what we're going to do is we're going to transpose for n. We're going to change the subject of this formula for n. And the reason we're doing that is because when we have an expression for n and evaluate it, we'll find out how many sides this polygon has, and we can figure out what regular polygon that is. Okay, so first thing to do is we can multiply both sides by n to remove the quotient. So now this n and this n cancel, and now we've got 135n is equal to 180 times n minus 2. Now we can expand the right hand side, so 180 times n, and then 180 times minus 2. And 135n equals 180n minus 360. Well, that's just the same thing as saying 180n minus 360 is equal to 135n, so we can just swap left and right around. And the reason I'm doing that is because now I'm going to subtract I'm going to add 360 to both sides, and then I'm going to subtract 135n from both sides. So if I add 360 first of all, these cancel out. So 180n is equal to 135n plus 360, and now I'm going to subtract 135n, and these 135n's cancel out. 180 minus 135n, well, that's 45n. Dividing both sides by 45, we've got 360 divided by 45, which is 8. So n is equal to 8. What regular polygon has 8 sides? It's an octagon.